Hey, iqkid here to talk about another gas law. So today we're going to be talking about Avogadro's law. To review real quick, there's Boyle's law, which relates volume and pressure. There's Charles' law, which relates volume and temperature. There's Avogadro's law, which relates volume and the amount in moles. And then the ideal gas law, which is the overall relation. Okay, so let's move on and look at the basic gas properties. The basic gas properties and their relationships, which are related by those laws we just looked at, are pressure, which we represent with the capital P, volume, which we represent with the capital V, temperature, which we represent with the capital T, and then the amount in moles, which we represent with the lowercase n. Okay, so yeah, all these properties are interrelated by by one or more of those laws. And Avogadro's law deals with the volume and the amount in moles at constant pressure and temperature. So V alpha n, alpha means proportional, V alpha n at constant P and T. So if the pressure and the temperature of a given gas are constant, then the volume of that gas is directly proportional to the amount in moles of the gas. So we can represent that with the equation V1 over N1 equals V2 over N2, which means the initial volume divided by the initial amount in moles is equal to the final volume divided by the final amount in moles. So we can represent this relationship with the expression V up arrow, which means as volume increases, so does the amount in moles, and as volume decreases, so does the amount in moles, and vice versa. Okay, so now let's look at an example. In this example, we have a 1.33 gram sample of CO2 gas in a volume of 121 milliliters. It has 0.0284 moles of CO2 gas added to it. So we're asked, what is the new volume? So in this problem, our step one is to convert. So we need to convert the masses of the sample into moles. So 1.33 grams of CO2 times the molar mass, so 42.01 grams of CO2 under 1 mole of CO2, and the grams will cancel and give us 0.031659128 moles of CO2. And next, part 2, step 2, is to write the formula. So V1 over N1 equals V2 over N2. Okay, and then step 3 is to plug and chug. So something to remember is it said that the 0.0, that this amount right here, it's added to it. So that means we have to add them in our calculations. That's not the final volume or final amount in moles. Okay, so then step 3 is V1 over N1 equals V2 over N2. So let's plug and chug. So the initial volume is 121 milliliters. And divide that by the initial amount in moles, which is 0.031659128 moles of CO2. Okay, and then set that equal to the final volume, which we don't know, divided by this right here, 0.031659128 moles, plus the new amount in moles, which was that right there. So plus 0.0284 moles of CO2. And then we need to isolate the unknown, so V2 is equal to 121 milliliters times 0.031659128 moles plus 0.0284 moles CO2 all over 0.031659128 moles of CO2. And if you plug that into a calculator, you're going to get 229.5437323 milliliters. Now we need to keep in mind the significant figures. So our final answer is going to be, the final volume is 2.30 times 10 to the second milliliters of CO2. Okay, so let's go on to another example. In this example, we are going to have a sample of SO3 gas in a volume of 75.2 milliliters, and it is expanded to contain 0.00325 kilograms of SO3 and a volume of 0.201 liters. So we are asked, what was the initial amount in moles? So step one is to convert. So we need to convert the kilogram amount into moles. So first we have to do the kilogram to gram conversion. So 1 kg is equivalent to 1,000 grams, and then multiply that by 80.866 grams of SO3 under 1 mole of SO3, and that would be the molar mass, and then that's equal to 0.040591512 moles of SO3. Okay, so then step 2, or part 2 rather, is to convert the liter amount into milliliters. So then with that conversion, we're going to get 201 milliliters. Okay, so then step 2 is to write the formula. So V1 over N1 equals V2 over N2. Okay, and then step 3 is to plug and chug. So V1 over N1 equals V2 over N2. Okay, and then let's plug in. So the initial volume was 75.2 milliliters over the unknown initial amount in moles, and then that's equal to the final volume divided by the final amount in moles, which was 0.040591512 moles of SO3. Okay, so then N1 is equal to 75.2 milliliters times 0.040591512 moles of SO3 all over 201 milliliters. So, and this we're just isolating the unknown. So then N1 is equal to 0.015186476 moles of SO3. So then we need to keep in mind the number of the significant figures. So then our final answer is going to be N1. The initial volume is equal to 1.52 times 10 to the negative second moles of SO3. Okay, So I hope this helped. If you have any questions or would like to make a suggestion for my next video, you can contact me through my email in the description or online at my website. The link is in the description, or you can just leave a comment in the comment section. And I'll get back to you as soon as I can. And yeah, so if you have any questions, don't hesitate to contact me. I'm happy to help. And yeah, IQ Kid signing off.